Good afternoon. My name is David Lopez, and today, with my group members Krishna Rana and Sebastian Campbell, we will be talking about wine's invisible architects, microbes from grape to glass. Today, we're going to uncover the microscopic world that shapes every sip. This presentation will explore how invisible microbes are the true architects of wine's character, from vineyard to bottle. Wine microbiology is the field that studies the microorganisms that influence both viticology and enology, essentially everything from grape growing to winemaking. These microbes play major roles at every stage, from the vineyard soil all the way to the fermentation tanks, driving the chemical transformations that turn grapes into wines. In this presentation, we're going to be taking a quick journey through the native microbial flora, the fermentation process, common spoilage organisms, methods of microbial control in certain tanks, and some modern techniques that are shaping today's wine industry.
Native microbiota on grapes. Wine isn't just grape juice with alcohol, it's a biologically driven process. Microorganisms like yeast and bacteria are responsible for converting sugars into alcohol, producing flavor compounds, controlling acidity, and even determining the aroma. Without microbes, wine simply wouldn't exist. The surface of grape skins naturally contains a variety of microorganisms. This is better known as the grape's microbiome. These native microbes start the fermentation process even before winemakers add any cultures. Yeasts are the main contributors. They convert the sugars into alcohol during primary fermentation, while lactic acid bacteria help later by converting malic acid into lactic acid, which softens the wine's taste. However, acetic acid bacteria can cause spoilage by turning alcohol into vinegar like flavors if oxygen is present, and we all know how vinegar tastes. So, native microbes add complexity to the wine, but they must carefully be controlled. Primary fermentation begins after the grapes are crushed and must be prepared. Yeast, mainly the species Saccharomyces cerevisiae, I hope I'm pronouncing that right, converts natural grape sugars into alcohol and carbon dioxide under low oxygen conditions. This is the main process that turns the juice into wine. Temperature is controlled throughout the fermentation process. White wines ferment cooler to preserve aromas, while red wines ferment in warmer temperatures to extract color and tannins, which gives it that more bitter taste compared to white wine. During this stage, yeast also produces important flavor and aroma compounds such as esters and phenols. Fermentation usually lasts about 1 to 3 weeks and is considered complete when the sugar levels stabilize and residual sugar is at a certain concentration, usually at a low enough level.
Malolactic fermentation is a secondary process that happens after primary alcoholic fermentation. Instead of yeast, this stage is driven by lactic acid bacteria, mainly Onioneclis onii. Their role is to convert harsh malic acid, found normally in grapes, into smoother lactic acid. This softens the wine's acidity and adds a creamier mouthfeel along with buttery aromas due to a compound called diacetyl. MLF is especially important in red wines and in certain white wines like Chardonnay. It helps stabilize the wine by preventing unwanted fermentation later in the bottle. However, if not controlled properly, other bacteria like Lactobacillus can cause spoilage, so winemakers carefully manage temperature, pH, as well as timing.
While many microbes play helpful roles in winemaking, some can negatively affect wine quality if they grow out of control. These spoilage microorganisms can introduce off flavors, unpleasant aromas, or even chemical changes like increased acidity, so winemakers need to carefully monitor and manage them. One another example is Brettanomyces, often called Bert. In small amounts, it can add earthy complexity, but when it takes over, it creates strong off aromas like Band-Aid or Barnyard. Another spoilage organism is Acidobacter. This bacterium uses oxygen to convert ethanol into acetic acid, which essentially turns wine into vinegar if oxygen exposure isn't controlled. And finally, lactobacillus, another type of lactic acid bacteria, can cause issues such as volatile acidity, mousiness, or geranium like aromas if it grows at the wrong stage of winemaking. Overall, winemakers balance good microbes and prevent the bad ones through sanitation, temperature control, and limiting oxygen exposure. Winemakers use different methods to keep microbial growth under control and protect wine quality. Sulfur dioxide helps prevent spoilage by acting as an antimicrobial and antioxidant. Sterile filtration removes unwanted microbes before bottling, and temperature control slows or speed up microbial activity during fermentation. And good sanitation prevents contamination throughout the winery. So together, these steps keep the wine stable and safe. Winemaking is basically applied microbiology because every step involves managing microbes. Winemakers select specific yeast and bacteria, control conditions like temperature and oxygen, and constantly monitoring microbial activity. They intervene when needed by adjusting pH or adding sulfur oxide, and they prevent spoilage through sanitation. Even the wine's final flavor depends on what microbes produce, so microbes really guide the entire winemaking process. As we come to the end of our presentation, we hope this gives you a clear understanding of how microbes shape every stage of winemaking, from the vineyard environment to fermentation, quality control, and the final product. Microorganisms truly are the hidden drivers of wine's flavor, aroma, and overall character. Thank you all for listening, and cheers.